Welcome to the next part of our series, Working with OpenAI, where we build Gen AI apps together. In the next couple of lessons, we will explore dynamic function calling, a powerful feature that takes function calling to the next level. And today, in this lesson, we will focus on the concept itself with a simple example. Along with that, we'll also create a function to fetch a live weather data and register it in the tool definition to show how real data, time data works. We'll cover key ideas like tool role, assistant role, and how they work together as interaction grows. We'll see how the assistant can handle multiple function call at once or call specific function dynamically based on the tool definition. And finally, we will also look at how to maintain conversation history by updating messages as the interaction progresses, an important part of building smart stateful AI apps. And this is a crucial milestone in your learning journey. So don't miss a bit, get ready, pick up your keyboard, and let's get started.
Let's begin by duplicating our first OpenAI call script, and in case you have not completed the first tutorial of setting up environment, you can obtain it from my GitHub repository mentioned in the resources, and further to that you can rename it to dynamic function calling or something like that. So let's first have a look at our first call which we made in our first script, and there we pass the prompt that tell me more about gravity, and the assistant responded with the right information. Perfect. But now let's ask another question. We will ask, how is the weather in Delhi today? And let's see what the answer we get. And as you can see, the LLM can't answer this. It does not have access to real-time data. It needs help from external sources like an API, and that's where function calling comes in. In this lesson, we will build a helpful assistant that can answer dynamic queries from basic maths like adding two numbers, subtracting two numbers, to real-time weather by calling real functions. Let's start by creating a couple of simple functions, and then further to that we will connect them using tool definition. Let's define a very simple function to add two numbers. We can pass num1 to num2. We are returning the value by converting first the input in integer values, and we are returning add underscore val. Similarly, we can define one more function which can be difference of two numbers. Let's check these functions. Perfect. Let's create one more function, and that is to resolve this issue. We will be taking help from API to get the real-time data. We will be using weather API over here. To get real-time weather data, I'm making use of tomorrow.io, where you can create your own API, and the weather API is free to use over here. So simply log in, create your API, click on view all core layers. If we scroll down in the left, we get weather forecast, and there you can see the get URL for weather forecast and also the example usage, and I'm on Python. So let's just copy this. So I'm just pasting it over here, and let's make some amendments before we define this as a function. So first I'm importing the request module. Make sure it is installed in your Jupyter environment. I'm making use of my own API key, create your own, and anyways I will delete this API key. We first need to have base URL. I'll just remove the parameters which we are passing over here. I'll just keep it till base URL, let's say till forecast. All right. Now the second thing is we are passing headers over here. Perfect. The first one is mentioning that we want the response in some JSON format. Then the second is encoding. Let's define parameters which we can pass to the request here while we are fetching response, something like this. Params is equal to params. So let's define the params over here. So in our params, what we are passing is one is location, which is the name of the city for which we want to fetch the data. Then we are also passing API key. So I hope you have created your own API key. And now we are fetching the response using request.getURL and passing headers and parameters as the argument. And here we are printing the response as text. Let's see. we get such a long response, and we do not want this whole thing. We want to fetch specific values, and for that we need to convert our data into a dictionary format so that we can fetch values with the help of key. And for that we need response to be converted in response.json. If we will print it, it will give us same output actually, but earlier it was a string, now it is a dictionary format. Now we can fetch the values over here using keys. We have timelines, then we have minutely, which is a list itself, and we are accessing the first element of this list which contains all the values. So we will go till this point and we'll save it in a variable called values. Let's see what we get out of it. So we have these values. Let's say all we want over here is temperature and humidity. Okay, so let's access that and save in separate variables. Maybe we can also fetch the value of rain with the help of rain intensity. Now we can do our own additions over here, defining the conditions as hot, pleasant, or rainy, or humid based on the values of these parameters. So let's define a variable called condition, where we are simply passing the value hot if temperature is greater than 35, else pleasant if temperature is less than 30, else humid if humidity is greater than 70, and so on, right? Now we want to return these values, and remember all we wanted is to create a function, right? So what we can do, we can simply create a function and return these values: city, humidity, temperature, weather condition, and so on. So we have this function over here which is returning these three values: city, temperature, and weather condition. And let's check this function once by passing a city name to it, and we get the required values. Now we have three functions in place, and while creating these functions we have deviated from our original topic, which is dynamic function calling, and this is the first step to it, where we have created two functions, two very simple function, and a third function which is calling an external API. And now let's talk about our next step, which is creating a tool definition. In last lessons, what we did, we simply created a schema, right, with the properties we wanted to extract from the given free form of text. Like in job description case, we extracted job title, skill, location, whatever. And in case of medical description, transcription, we extracted other properties. But it was a purely LLM guided extraction. We were not actually calling any real functions, and here the power of actually function calling begins. Now why we are calling it a tool definition? Because in terms of OpenAI language or terminology, these functions are tools which will be incorporated or described in this tool definition, and they will not be executed from here. It's just again a kind of schema which we are providing to detail what are the tools available over here once we get a prompt, so the LLM knows that this is the list of tools. We already done the creation of schema and in our last lesson, so in similar manner we will be creating the tool definition over here. Let's say our first function is add number. While in our last lessons we also defined the type as function, but those were not real functions. Here we have real functions which will be called at the back end, and in a dictionary like we did earlier. And we started with the name, we gave a description, we passed the parameters. In earlier cases, in our last lesson, parameters were the value which we wanted to extract. Here in this case, since we are passing real functions, the values which function will be returning is handled by the functions itself, and here we want to specify what values we will be passing in the function as part of properties. And we can define it in the same way by defining the type, and if any description is needed we can associated description also. And further to this, we can also tell what is the required field in the function, and we know that we need both the numbers in this function. Similarly, let's define the other two functions as well. Let's incorporate them. So we have add number, we have diff number, and we have get current weather, where in weather we have a property called city, which is a required property and is just getting the current weather info. That's all. All right. So we are done with our second step of defining tool definition. Just to reiterate, our purpose here is to understand how GPT knows when to call which function, and for that we will be constructing different kind of prompts, and we will be looking at how function calling is working dynamically. So first let's have a look at different kind of user prompts, particularly related to what the functions we have defined over here. So let's begin the conversation over here by defining the prompts which we have been doing earlier. So our first message is in the system role. At the start of the conversation, as a developer, you define how GPT should or how LLM should act throughout the session. Then we also know about the user role, right? So user role is whenever the user types or speaks a request, it represents a real human question or instruction. Then we will be talking about two more roles over here further in this script, which is assistant role and the tool role. So assistant role is particularly LLM's own response to the user, or it is a decision to call a tool. We will be looking at it. And then there will be a tool role which will send actual results from the function or API back to the LLM for reasoning. So we will look into that as well. Here we can see different kinds of prompt. The first one, what is the capital of the Delhi? The second one, what is the difference of 7 and 4? And the third one is little complex. First add 7 and 4, then subtract the result from 18. And the last one is how's the weather in Delhi today? So as you can see, each of the prompt leads to different requirement of functions. Clearly the diff function is needed over here, and here the result of first function leading to as a input to the second function of diff. And here we are not needing these first two function add or diff, we are just needing the weather function. And if you look at the first prompt, what is the capital of Delhi? None of the function is required. This is where the dynamic function calling is needed. And here we will see how the LLM is going into that. So let's first begin by appending the user prompt 1. So this is the value of current messages variable. Let's create a request to chat completion API like we have done earlier as well. And since we are using tools definition, we will pass that to with the argument tool choice is equal to auto, which can have other values as well, like none in case we do not want to call any function, and we can specify the function which we want LLM to call, and auto is the case where LLM can choose and call the function from the tool definition which it thinks is appropriate. And let's print the response over here. So since our prompt is currently not related to any function, if we see over here, what is the capital of Delhi, none of the function is appropriate in this function. So here you will see there is no function call, and the tool call value is none in this case. That is, GPT has not called any function, and it has given its own response as well, simple response, which is Delhi. So that was one case. So let's park this. Now let's see this case where we are passing user prompt 2, and this is how our messages should look like in this case. That what is the difference of 7 and 4 in the user role, and what happens in this case. So if we run this, you will clearly see that tool calls is not none in this case. Tool calls has again a chat completion message tool call, which is showing that the arguments are 7 and 4, which it has picked from the user message, and it is supposed to call the diff number, and which is correct, right? So LLM is able to dynamically think about the function it has to call. It is able to pick up the arguments which has to be passed to the function. But if you see over here, it is not executing the function. There is nowhere you can see that the result is there. It is just right now telling that this function has to be called with this argument, and it is not executing the function. And now it is developer who has to execute the function, which is identified by the LLM. So let's do one thing. Let's save this response in a, so if you notice closely, the role over here is assistant, which indicates the message is returned by LLM, and it is also able to decide which function to be called. And so let's save it in a variable called assistant message. And what we will do, we will fetch the value like which we have been doing earlier till this point. Let's see what it contains. So we have specifically come to this point. Chat completion message, content is none, role is assistant, and functional call is none. There is no function which is being called. And here the tool call comprises of the ID of the function which is, or the tool which is to be called, along with the arguments and the name of the function which is to be called. Perfect. So in this case we have a value for tool call. Now let's access that value. Tool underscore calls is equal to, and with the help of assistant message we can access this tool calls. And if the value is not none, what to do in that case? So if it returns any value, then in that case we will update our message to the LLM by appending another role which is of assistant, which will be calling the tools which are retrieved from tool calls. So first of all, this is a dictionary which we are appending it with multiple keys over here, and then we are retrieving the tool calls listed by the previous LLM response, which we can fetch from model underscore dump method for each tool call in tool calls. So right now you can see only one function being called as needed, right? But we might get, as we will see further, more than one function, okay? And that is also called parallel tool calling or parallel function calling. And once we have appended the message, let's see the updated message in this case. It is messages. All right, so now we have got a new message where we are able to retrieve the prior state, right? Initial role setup, initial user message, and then we are also able to retrieve the response and send it. We are ready to send it back to the GPT. As a developer, we have fetched the tool which is identified by LLM response. So let's see how we are running the tool first. So we will be first running the tool based on the tools identified. So we have a list already, right? Tool calls which we have just created. If you see tool calls, it has only one entry of function which is diff number, and for multiple ones we will have a more number of functions, we will see later. So for tool call in tool calls, all right, we are retrieving the function name for each tool call, and that you can bring again with the help of tool calls dot, how many times I'm using this word, anyways, dot function, and within that we are retrieving this name. So dot name, right? So we are able to retrieve the function name, and also we need to retrieve the arguments, that is the input which is to be given to the function, and that we can retrieve with the help of again tool call function arguments. We can pass this as a JSON with the help of json.loads method. How to call a specific function? Our old if method here, if function name. Right now, I mean, there can be better ways to do that, so we are just simplifying it. We can maybe maintain it in a dictionary list number name of functions, and then we can refer it. Maybe in some next script we might do that, but just let's keep it simple this time. So we'll say that if function name is this, if function name is add number, then call add numbers, proceeded with the whatever arguments are given to this. And on similar line, we can add elif statement, and we can add else in case no function is identified. These are the manners in which we can call the specific tool identified. And then once the tool is run, once that particular function is run, we need to return the response or received from that function. And how we can do that? Every time we are running that tool identified, we can append in the messages with the role to be noted as tool. So tool, that means our function, the one which we have written, is returning this result from here, and tool call id is already being identified by the LLM. So this is how it is working. So let's run it. Yeah, function name equal to, okay. Okay, so let's see the updated message again. So we have system role added our original message, then function call which is identified by the assistant or LLM along with the arguments and the function identified, and the role and the result which is returned by the identified function once executed. Now finally we have this, right? So let's do one more thing. Let's return this message to the, because at the end it will be called through some interface, right, conversation, where we need to return the result in some natural language, right? So we can finally pass this again to chat completion API to receive the final response. Let's see. So this is the final response which we get. The difference between 7 and 4 is 3. And finally we can make use of something called markdown to display our message here. Let's see how we can have a look at this right now. So it shows us the message like this. So we are done with this. Let's try the same thing with other user prompt. For now, what happened? We called add function with the help of our user prompt. Let's try another prompt out of the list which we already did. Yeah, here. So we will just comment this and we will pick this user prompt 3 where we are asking how's the weather in Delhi today. So let's see how our LLM decides this time and how the further conversation takes place. So let's run this whole. So let's see the first response from LLM once it receives the user prompt, how's the weather in Delhi today. And at this time there is a function call, and amazingly it is get current weather. So LLM is able to identify, it returns in the assistant role the get current weather. It identifies the argument as well, that the argument here is city, and the function is to be called this one. And this is retrieved and this is further passed to the assistant chat completion API to get the tool call finally that this function is to be called, and which is further executed over here, right? Get current weather, and the argument is passed as city, and we have our result over here. It's hot right now in Delhi with a temperature of 35.9 degrees Celsius. And finally, see, this is the final response in the natural language. The weather in Delhi today is hot with a temperature of 35.9. Amazing. Is so far what is done, only one function is being called, right? because our user prompt was according to that. Let's see what happens when we have a user prompt which needs two functions like this. So here it says first add 7 and 4 and then subtract the result from 18. Now the important point to note over here is LLM may interpret it differently every time we will run. So sometimes it will call one function followed by the other function, or sometimes it will call the both of the function together, in which case it will be called parallel function calling, or in some cases it will be chaining the response of one function with the other, but all within this code. So let's run this and see what turns out, how it turns out to be. So let's see over here, it says tool calls. So it has tool call of number 7, add number, and so right now it only calls one function. Maybe other time it will call both the function. In that case it will be parallel function calling, but let's see if it is finally able to give us the response or not. So it says first add 7 and 4, subtract 18, and it earlier it identified add number. So it goes to this, it gives us a response. That message is sent back to the LLM with this tool response of 11, sum of 7 and 4, and finally this message is sent to the final response. And let's see what we get. First add 7 and 4 to get 11, then 11 from 18. Yep, it gives a correct result, though it is not calling the other function in this case. Let's try it by changing prompt. So it's up to the prompt and interpretation of LLM, but here we want to see the case of parallel calling. So let's try another prompt. So we can say add 7 and 4, track addition result from 18. Let's try this. So with this prompt, this change prompt, luckily we are able to see the scenario. So as you can see over here, there are two calls over here. The first function is add number, which we have already seen, and then there is another function also called, which is diff number, which takes two argument. One is 18 and the other is 11, which is obtained from the argument of 7 and 4. So if you see over here, when we append the result of tool calls back in the messages, we get two tool IDs over here, right, with arguments. Here two functions are being called, and then finally the messages appended with this two calls of two functions with their arguments, and the result is returned by them. So 7 plus 4 is 11 and 18 minus 11 is 7 is returned by these two tools. And finally the response is shown over here. 7 plus 4 equals 11. Subtracting 11 from 18 gives you 7.
So I hope everything made sense to you. If you found this lesson helpful, don't forget to like the video, subscribe to the channel, and drop a comment below. In our next lesson, we will apply what we have learned by building a real-world project where users can fetch both the stock price and related news using the Yahoo Finance library. And it is a fantastic hands-on addition to your portfolio. Make sure to turn on notifications so you don't miss any lessons in this exciting series, Building Gen AI Apps with OpenAI. And I'll see you in the next lesson.